Planning a wiring harness in a spreadsheet takes hours. Manual data entry, crawling datasheets for part numbers, formatting, and duplicating the same data across multiple locations. Now imagine you could select your ECU, your PDM, your sensors, and body connectors, and have all the correct part numbers and pin descriptions imported, ready for you to start making connections. Well, that's exactly what EasyWire does, so let's walk through it. Before we get started creating any wiring harnesses, we first need to define our available wire types that we have on hand. You will come to the parts library here and you can click wire types. From here, you'll see that we've already enabled, we use spec 44 wire personally in our workshop. We have some mil-spec wires as well, but we also have a bunch of TXL wires and things as well. So we can just search TXL and we can include specific gauges. So we want to see all the 20 gauge wires, TXL, which have a secondary wire colors, and apply the filters. We could bulk enable these and come up and hit enable selected. But let's just say we just want to have the basic colors. So we'll just have all of these on hand. We can enable these as selected wire types, clear the filters, and now we can see these are all the wire types available to us when building a wiring harness. Now we're ready to start creating a wiring harness. So if we come into wiring harnesses, we can create a folder, call this 2026. We can put all projects from this year in here, create a new wiring harness, call this link G4X Monsoon, Toyota Starlet. We'll select our measurement unit, create a wiring harness. Now at this point, what we could do is import the device. So you want to import the G4X Monsoon, come up to here, just search G4X, and there we go, we've got the Monsoon. We can customize the connector name or we'll leave it as it is. We'll import the device now. There we go, we've got our connector name, we've got our connector part number, and we have all our pin descriptions for that ECU. We can also organize the tabs here. So if we hit add edit tabs, we can rename this one to ECU. Add a new tab, we'll call it injectors. And we'll have another one for sensors. Injectors, we can select a connector from the part library here. So we'll have a two-way connector and we will use the GT150. This one here, we like the black variant of this connector. Use that and we'll call it INJ in all caps. We can hit create multiple numbered connectors. So we're going to have 4 injectors on this project. We can import them there. There we go, we have 4 injectors. And we can, our sensors, we could import a device. Let's go for a map sensor. And again, we can customize the name, import the device. And there we go, we've got our map sensor, correct part number, got the pinout descriptions here too. We actually probably want to have some body connectors. We'll create a body tab. And one of the things that's really useful for this is we could import the body connectors for a vehicle here. And so this one is added to the library by us. And we click this and it comes with 3 connectors. But if you wanted to check it out first, we can go over to the devices, EP91, there it is. And you can see the different connectors and the pinouts for these connectors. And you can also customize anything that you see in the library. So if you want to rename any of this so that in future when you import it to projects or after you've imported it to a project, you can still come and customize your own version, rename some of these parts and then go back to the harness and update the custom version. So we'll show you that right now. So we'll go back to our wiring harnesses and our body tab. Whatever tab you are selected is where the device or the connectors will be created. So let's import the Starlet body connectors. Now you can see all these descriptions come through. But let's say we want to remove this description or change it. How we would do that is we come into devices, system library, there we go. And we can create our own custom version. And you can add additional pinout documentation. We can change the picture. This is our own version, and we can make any changes we wish to this for our own purposes. So we could change this to diag and ABS. Again, just change that to diag. We can update the device. Now this is our own version of this device. So you can see it's labeled here with your device. So let's go back to our wiring harness. If we go in our body tab, you'll see this has got the system version, but we can come in and use own version of this device connector. You'll see the update there. Once we customize any of these become fixed to this instance of this connector. So the first thing we'll need to do for our ECU is connect some form of power. So here's our ignition switch 12 volt power. We will add a splice. We'll call it 12 volt PWR. And I like to prefix it with SP, but you're welcome to name it however you wish. Add the splice. And we will take, the splice will appear at the very bottom here. We can now take the power output from here and go to the splice power. We'll pick pretty large wire for this. So we'll go with a 12 gauge wire. And you can see that connection has been made on both sides. We are also able to add wire idents. So we could give this an ident of 1. We give us a little brown band on that wire. You can see that updates on both there. Now, we need to give power to the ECU. You can see all the descriptions for the device are now displayed here. So there's our 14 volt in. And we will select a TXL red wire for this one. And if we go over to our ECU, you'll see that wire is already there. And you can see the description, 12 volt, is automatically populated. But if we wish to customize it, we can just come in and click and type power supply. And that is now fixed. Let's start making some connections with our injectors. So we link ECU, we start with injector 4. So we can just start typing INJ 4 and then .1. And we'll select, type -6, that gets me a spec 44 20 gauge wire with the color code 6, which is blue. So let's do ING, and again we're going with 3.1 -6. We go over to the injectors themselves. You can see the connection is automatically copied over. So if the connector has a device attached to it, like this one here has this link ECU device, these ones do not have any device connected to it. So that automatically copies the device description to here. So we can do the same with our 12 volt power splice. 12 volt power splice, and you can see ignition switch 12 volt comes in there, and we'll just do -2. And same for all these. One thing to note is because these plain connectors, if you like, they don't have a device behind them. These are hard-coded descriptions. So if we go ahead and remove this connection here, you'll notice that the description stays. So this must manually be deleted. And then if we make the connection again, the description will copy over again. But if we don't delete that, it won't copy anything over because it sort of hard codes it. But if you're making a connection between two devices, the description will be grey, as you can see here. It's greyed out, and the reason for that is because the description is auto-generated from the description. So if we have a look at this aux1 and we assign a tacho to it, you'll notice that the description is automatically populated, and it is in the format of current device and then connected devices cavity description. So we can go for a pink wire here, have a look at our body connector, and you can see tacho aux1. So again, this is all customizable. So it's great if it's grey, sort of greyed out, then you know it's automatically generated. But if you click, you can come in and say, I don't know, PWM if you like. But this will only attach to this side. So we go back to the device on the ECU, it's independent, and this one's just automatically generated. Let's see, what else can we add? So we've got the map sensor. So we'll need a splice. I'd like to go to the ECU tab, and I would put my 5 volt splice here. So SP 5 volts and SP essence or ground, I like to call it that. Add these two here. take a single. Now, if you notice, there is no description on these at the moment. On this single cap, these are essentially a single cavity. So if I make a connection from ground out, but I actually don't like the terminology for link, so let's go and customize that. So we'll go into devices, I'll search for monsoon, and we'll create our own custom version again. Let's have a look. So we have, where's 5 volt? So ground out, we'll call that sensor ground. That's what I prefer. You may prefer something different. 5 volt sensor supply. Everything else I think I'm quite happy to live with. Although I always use the knock input here, so I'm just going to remove that and I'll just call that one knock. Save that. Now if we go back to our wiring harness, we now need to update this device, use my own version of device connector. You'll see this knock and shield ground was fine. This is updated. So if I now make a connection to SP sensor ground, set the wire type to -5, you can see sensor ground is now here, and I can make the connection to the map. I can see sensor ground. And this is just a lot easier than having to go between tabs and figure out which color you're going to use. This is obviously a lot easier than going between the tabs to figure out the pinout or using an external sheet. If you add all of your sensors as devices in the parts library, this is going to be a huge time saver for you. So again, we'll select so if I search 5 volt, there you go, you can see it. Connect to that, and the description comes over here. And we'll go for an orange wire and map. There you go, 5 volt signal. There we are. We can have a quick look at the sensor, and you can see that's all added there. Orange wire as well. Map sensor signals, so we can, without having to go back and forth, I would normally put it on the AN volt 1. I would put the map sensor on. If we were going to use an external map sensor, that is. You can have your own preference here. And there we are. As we can see how quickly we can sort of put a wiring harness together, and we're not having to type anything here, that's really the beauty of this here. If you're using a lot of devices, the aim is you don't want to have to type descriptions out manually, especially if they already exist. Okay, so we need to add a ring terminal for the ground. So I'll just call that GND. We'll connect that to GND. Again, we've got another ground here. You can see the description's copied over because this connector does not have a device or anything connected to it. So this is the ring terminal, and that automatically gets ground added there. I also have this little feature, shows you the total CMA, which is quite good for selecting which part would be suitable. Connect to the ground again. Again, we'll use black wire. All right, so now we're starting to get somewhere, but we need to figure out our wire lengths. So at the moment, we're very close to releasing the visual side of the software, but for now, you're going to have to type in the branch points and the lengths in a written format, which, if you're quite technical, is usually quite simple and straightforward. So in our wiring harness, we might have a branch at the ECU, so we could call it ECU, and we might have another branch at the engine. So I might even just have 2, so we'll have A and we'll have B, and there we go. You've got 3 branches, and now we can define our lengths. So if you start with a branch, and then from here you can select each item that comes off that branch. So let's have ECU A. We define our length. We'll go with 250 mil, and then you see we're automatically selected, so we don't need to use the mouse. We can hit enter, and then we can select another point. So let's go for branch, ECU branch to the A branch, and we can hit tab, and we'll say that's 500 mils. And then if we got anything else, yes, we've got a few things inside the car. So we actually have this BD1, and that is, we'll say 300, And we've also got BD5, and we'll say that's 400. And so there we've got some lengths. And if we go to our cut list, we should start to see some items will have a full path from start to finish. So you can see this comes from ECUA, it goes to BD15. And so because we have a full path, we actually get a length on this. And if you can see these missing lengths is because there is not a full path from these items all the way to the other side. So we go and have a little look here. The branches will always appear in these lists, but the connectors will only have one length defined to them. So as you add more as you've used the connectors, you'll no longer see them in one of these two lists. So if you can still see the connectors, you've not assigned the length properly. So let's go to branch A, to branch B, and let's say that's another 300. And from branch B, we'll just put all the injectors on it. So injector 1 is the furthest away, we'll say it's 500. So INJ2 is 420. And then INJ3 would be 340. And INJ4 would be 260. There we go. And then branch A will have the map sensor. The map sensor will be 600. The ground point as well, we'll make that 500. And this connector, we'll say that's 770. Okay, now you can see all we've got left is these branches, but we've already defined lengths between each of these branches, so we no longer need to use them. And we have this part here. This again is another text-based way of placing a splice in a harness. So we will set the 12 volt power splice, we will put that between the connector that it's on, which is, it is on BD1, and it's between BD1 and the ECU branch. So let's put it there. It's closest to BD1. We will make it 100 mils from there. We've got the 5 volt, so that goes between the ECU connector and the ECU branch, and we'll place it closest to the ECU, and we'll say it's 60. Place that one there, and we'll do a similar thing for the sensor ground space. We'll say that's 80. We'll place the splice. Now we should have a full cut list for all the wires. So you can see all the wires have a length here. We are able to define additional length settings here. So for a straight lay, a typical amount extra length might be 100 mils. You can round them up, but if you have a concentrically twisted harness, you can have a percentage within a minimum additional length. So 18% is typically what we would use, and we'd always want at least 100 millimeters. And depending on what type of harness it is, if you've got really short wires, you'll find sometimes 18% is too short. And so this allows us to sort of negate that issue. And again, you've still got the rounding, and you'll see none of this has been changed until we hit save. Hit save. Now you can see there's all the lengths there. The shorter ones will be pretty much identical because they are hitting that minimum additional length, but the longer ones will have, the 18% applied to them. Okay, perfect. So the last thing we've got here is your bill of materials, and you can see your total length of wire, and this is based on the cut list. So this isn't, as you can see here, you've got the additional length factored in here. So this is including your additional length. So that's something to consider, that you're charging for what you would be cutting rather than planning out the exact length that it might be calculating. You've got the additional length factored into this quantity here. You can export this as a CSV, and also you can buy any of your connectors from Costa Technic, who we partnered with. And that makes it really simple to source all your parts if you're using the Costa Technic parts from the part library. And that is it. We can go into more depth about all these other parts. We have a documentation section. We're available to jump on if you want to do a screen call. If you wanted to get some time with us to go over the software, you can see the book-in link in the description. Any other questions, you can drop us an email, or you can sign up and try it yourself, and you can get a refund in 14 days if you don't like it and you haven't exported anything. Thanks.